Welcome. This is a building and crafting example. The red marked task nodes represents the buildings and the blue marked represents the units. Each of these task nodes have two conditions. One condition is the consumer condition and another is a trigger condition. The trigger condition is set to trigger and is directly connected with the button. So if the button is clicked, it shortly switches to a success state. And if the consumer condition is also in success state, then a task will be in success state and the product will be built. So the consumer condition has access to the container. There are 3 containers, one for the units, one for the buildings, one for the resource, and one container manager which contains all the container. And so just this one must be referenced to the user for the consumer condition. So this is the CM. These are items which are defined in the container, and if it is a minus value, then it will be removed, and the plus and it will be added. So for these resources, I will build a barracks. The green mark means they will be consumed. That means it will change. It will really change the values in the container, and if I would remove it, so then it wouldn't be changed, but it would be a requirement for. This can be used if you, for example, want a precondition that a farm must exist. So, and then I would simply add the farm in this way. And I would remove consumption because it's just a requirement. I need a farm to build the gold mine and for the gold mine, and so I could use this behavior for example, destroying the farm. And if the farm is destroyed, I cannot build this because this wouldn't be correct, because we wouldn't have a farm at all. So I'll remove it for this example, and so these must be then activated externally, and the example is here for these. It is on build tree item, and it is in the method item build method, which means the item is built. And then I call this method consume externally marked items, and the externally marked items will be then consumed. Then I manually activate the outgoing connections and the task itself again, because I want repetitive building. So if it is possible, then I can build a new building from the same. Yes, and then you also have data instances where you can define your prefabs that should be instantiated, your attributes for that what should be instantiated. As example, I defined the name, the image for the icon, for the button, the build time, and the prefab itself. And normally there would be much more. I have also data provider, and this with this you can get these items. So there these items live. The data entries are connected by name, So if this node has the same name as the data, then they're connected. Because they are dynamically created, I need some kind of automatic mapping, and I use the name mapping, which is then, I guess, in the Singleton main UI controller. And at the beginning, I check for so I create the items, and then here is the build to data provider, and then I look for the name, of the data entry and compare it with the task name, and if they are equal, then I have my data entry. So it works automatically if you name them, if you give them the same name. So let's run the example. So the UI is connected to the graph, and so you see this one is active, so I can build it, and if I build it, then the connected items will be then also activated, and then they can build too. The graph cares about the resources and the dependencies. The UI implements the queues. The items itself has its own queue. They must maintain its own queue because I can build more of them. And there is a global queue inside the main UI script, in the Singleton script, which then process the build items in order. That means the buildings will be processed in order, and the units, it's not in the same way. The units can be built all at the same time, because I defined it so that units can have comes out from different buildings, and they can build parallel. So I built the other buildings, and you see they will be activated. And I can also show you that they consume the resources if they will be activated. So for example, this one, if you look at the resources, next time it will be I missed something. So it would be it was removed. It removed the items. So no 200 gold, and stop. And if I would refund it, I would get back this 200 gold. Yeah. So I don't know why I can't build this archer building, because I changed it. Okay, because I changed it for in the I didn't change it back, so I have to do this now. It is pretty simple, because I just have to connect this one, and I wouldn't like to have this connection. So if I start this example again, so these are changes, and this is a change that you would make later when you want to change something, and that's so simple. Right? Not much to do. I just want. So at all, I will describe this example in the documentation, and there you can see how to. So what you have to do if you want to extend this or change this example, how to control the graph from outside, because if I delete, then I have to, if I make special things, then I have to control the graph from the outside. If you make it from the scratch alone, hard coded, then you will not able, then you're not that good overview later for your game. And if you have to change something, then it will be big effort every time. And so you can understand very fast what you can build, what is the order, what is needed for what. And if you click on the task, you see what resources they need. Very fast, so you can check very fast because it doesn't change the view if you click on the same items. And it is also very simple to extend it because you add just a new node. I would recommend you duplicate a node unit or building node and then connect it. Then create a data entry with the same name, and that's it. It's very simple to extend it. And now you see, because I changed the graph, I can build the archer building. Oh, I have this, I don't need it anymore. And yes, and units can be built parallel because I defined it so that they can come out from different buildings. So why not? Just for the example. So the prefabs are instantiated in this way, just for the example. And I would, if it's finished, I would click on the building and would place somewhere, and the units would come out from the buildings. So this is then your implementation. How do you want to implement it? It's your decision. It can be also used as crafting, so you can build some products and you don't have to instantiate here something. Maybe then you have an inventory where you just instantiate goods, products, and so on. So if you use the system, you will have a very big advantage in your game. You will have a very good start with this asset. I will use it in my artist scheme for building and for units and buildings, for mission system, for tech tree for tech tree, for research tree, and also for cutscenes and so on, because it's very powerful and it's very simple to handle. And in the later game development, you have the overview, which is which is very big advantage. So that's it. That's all what I can tell you to this scene, and thank you for watching.